Here I have a 120 to 12 volts transformer. That means that if we put 120 volts to the primary, we get 12 volts on the secondary. However, they can also work in reverse. If I put 12 volts to the secondary, I will get 120 in the primary, which is what I will do now. That's why I have this neon lamp on the primary to see if I get a voltage. Remember that neon lamps work from 80 volts and above. Here I have my DC power supply to feed the transformer. But wait, everybody knows that transformers work with AC. So if I fed DC to the transformer, the neon lamp should not work. Let's see. I'm going to connect. And indeed, the lamp is not on. But if you noticed, the lamp went on for a fraction of a second the moment I connected the terminals. The same happens when I disconnect. You see? So the lamp turns on every time I connect and disconnect. And this is because we get a voltage on the primary when we connect a voltage to the secondary, because the magnetic field is turning on. And when we disconnect, the magnetic field collapses. This is the principle of the transformer. It needs a variable magnetic field, like the one we get with AC. In DC, the magnetic field only varies when we connect and when we disconnect. So in order for the transformer to work with DC, we need to continuously turn on and off the power. And in fact, this is the principle of switch mode power supplies. They use not AC, but pulsating DC. Okay, so in order for the transformer to work with DC, we need pulsating DC. That is, we need to connect and disconnect the power to the transformer, and for that we need an oscillator. There are several types of oscillators, but in this video we will see a very curious one, which is the carbon oscillator. And here's our carbon oscillator. We have our transformer. The neon lamp is in one side of the transformer, and in the secondary, which we are using as our primary, we have the power supply, DC. The positive is connected to one terminal of the transformer, and the other terminal is connected to the negative, but there is a piece of pencil lead in series. The pencil lead is barely touching the terminal of the transformer. And this produces the oscillation. Let's see it work. I will apply 8 volts, and there it is. It's kind of unstable, but it works. Well, of course, this is a very inefficient oscillator. It is unstable. The carbon lead needs to be changed periodically because it wears. But this system was in fact used in the early days of radio to transmit AM signals. At that time, there were no semiconductors, nor even vacuum tubes. So people had to work with what it was available. And I think this is a very clever way to produce oscillation. Thanks for watching and see you in the next video.